Alright, here is your homework on dividing radicals to practice that skill. So first, look to see if we can simplify before we have to multiply and rationalize the denominator. So 20 divided by 4 is 5. 270 divided by 3, well 3 goes into 27, 9, so it's 90. And then 90 is 9 times 10, so the square root of 9 is 3 times 5 is 15 root 10. Here 6 divided by 2 is 3, so a property of dividing roots, if they're the same root you can divide the inside, so 7 goes into 336 evenly, 48 times. 48 can be written as 16 times 3. The fourth root of 16 is 2 times 3 in front is 6, and you're left with 6 and the fourth root of 3. Number 3, same root, so we can just simplify the by dividing the inside. So in this case, because they are exponents, dividing means we subtract. So 10 subtract 5, and 16 subtract 4. Then, to simplify this, we need to understand that 3 goes into 5. So the nearest number that would be cubed, and there's still 2 left over. And 12 is fine because 3 goes into 12 evenly. So 3 goes into 3 once. 3 goes into 12 4. Oops, that's a B. And what's left under the cube root is a squared. So again, 24 divided by 4 is 6. 5 goes into 225. 45 times. Subtract the exponents. Now 45 is 9 times 5, and 18 is fine because you just divide by 2. So the square root of 9 is 3 times 6 in front is 18. Divide the exponent by 2, so it's x to the 9th, and what's left over is the square root of 5. Number 5, the cube root of a negative number is fine, but first I'm going to divide. So negative 324 divided by 2 is negative 162. Then I have to think what cube root goes into that evenly, and that's negative 27 times 6. And the cube root of negative 27 is negative 3 with a cube root of 6 left over. Number 6, the fourth root, so first simplify. So 2 into here. Actually, I won't even simplify it first. So in this case, I'm going to separate it. So the fourth root on top with the fourth root on the bottom. Two different variables, notice. So you can't combine them together. So let's just look at it one at a time. So the fourth root of 2, that's prime. 7 can be written as 4 and 3. So I'm going to do that. So 4 and 3, because 4 goes into 4 evenly. The denominator, the fourth root of 25, is there a number 4 times itself? Yes. That number is 5. And 4 goes into 4 once, so that's just 5n. Here, 4 goes into 4 once, so there's one m in front. And then the fourth root of 2 and m cubed is left behind with a 5n underneath. Number 7. So this means the same as this. We can separate the square root. I'm going to write the square root of 20 as 2 root 5. So 20 is 4 times 5, and the square root of 4 is 2. Then I'm going to multiply top and bottom by root 5 to make the denominator a rational number. So the numerator is the square root of 15. Root 5 times root 5 is 5 times 2 is 10. Same thing here. So I'm first going to look to see this is 2 root 2 and 2 root 14. So notice the 2's divide out. So then I can focus on the radicals. So to make it a rational number, I'm going to multiply top and bottom by root 14. So it's root 28 over 14. 28 is 4 times 7, so it's 2 root 7. And 2 goes into 14 7 times, so it's root 7 over 7. Number 9, this is all prime, so I'm just going to multiply top and bottom by root 5. So the top is 3 root 40. The bottom is root 5 times root 5, which is 5 times 8 is 40. They do not cross out. 40 can be written as 4 times 10. So the square root of 4 is 2 times 3 in front is 6. And 6 and 40, the number that goes into both is 2. So that's 3 root 10 over 20. Here, I'm just going to reduce the fraction down first. So what number goes into both evenly? So that would be 6. So that's 3 over 5. Then I can separate it. Then I can multiply top and bottom by the radical of the denominator to make the denominator a rational number. And you end up with root 15 over 5. Turn the page. So simplify what you can first. So 5 goes into 15. Three times. Subtract the exponents and you get n cubed. So it's a good way first to simplify it. Then multiply just by the radical part, top and bottom. So you end up with the square root of 3n cubed over. Remember, they undo each other, so you end up with 3 times 2 is 6, and then n cubed. Number 12. This is all under the square root sign. So I'm going to multiply top and bottom by 2x to the 4th y, square root of that. Now the denominator is going to be 2x to the 4th y. The numerator, I have a 4. X to the 4th, the square root of that is x squared, and what's left over is 2 square root of 2y. Recognize 2 goes into 4 twice. The x squared makes the x to the 4th and x squared. Still have a y and still have a square root 2y. Oh, I forgot a y on top. So when we multiply this, I had 4, there's a y here, and the x squared. So the y's actually cross out. So you have 2 square root of 2y over x squared. Alright, number 13. This is going to require what's called the conjugate. Now first, I'm going to simplify what I can before I get started. So the denominator is 3 root 2. And then, actually the denominator, to rationalize it, we just multiply by root 2 top and bottom. So root 2 times root 5 is root 10. Root 2 times root 6 is root 12. Root 2 is 2 times 3 is 6. If you wanted to, you can write that as 2 root 3, but it still is what it is after that. There's nothing more that simplifies. Here, I'm going to write the denominator in a simpler way. So, square root of 8 is 4 times 2. So square root of 4 is 2, but there's a 2 in front, so all of that actually becomes 4 root 2. Then I multiply top and bottom by root 2. Remember, 8 is the square root of 4 times 2. Square root of 4 is 2, times the 2 in front gives me the 4. Alright, distribute, so I get 4 root 2 minus 2. Root 2 times root 2 is 2 times 4 is 8. 2 goes into everything evenly, and you have your answer. Number 15, this one's going to involve the conjugate because the denominator is a binomial number. So we have two different numbers. So we're going to go 4 plus root 3. That's the conjugate. So the numerator, 4 times 12 is 48, and 12 root 3. The denominator is 16 minus 3. So altogether we have 48 plus 12 root 3 over 13. Again, the conjugate, so 6 subtract root 2, top and bottom. So I end up with 6 root 2 minus 2, and then 6 times 6 is 36. Root 2 times negative root 2 is negative 2. It's like a difference of squares, so we don't have that middle number. And then we have a rational number in the denominator. 2 goes in everything evenly, so you could actually write it like this in lowest terms. All right, last two. Binomial. The top we're going to have to FOIL. So when I look at the top, I'm going to draw a box. You have 2 root 3 and minus 3. You have 6 and root 3. And we're just going to multiply this out. FOIL, first, outer, inner, last. So this is 12 root 3, negative 18. Root 3 and root 3 is 3 times 2 is 6. And this is negative 3 root 3. So combine like terms. So in the numerator, we have 6 take away 18, so that's negative 12. 12 take away 3 is 9 root 3. The denominator, we don't need a FOIL. It's a difference of numbers here, squares. So 6 times 6 is 36. Negative root 3 plus positive root 3, that's negative 3. So we have negative 12 plus 9 root 3 all over 33. 3 goes into everything evenly. So we could have negative 4, 3 root 3, and 11. All right, last one. So do the conjugate. So that's 4 subtract 3 root 2. 4 subtract 3 root 2. So the numerator, I'm going to do a FOIL so that I can get all the numbers that I need. So 4 times 6, 4 times 5, negative 3 times 6, that's negative 18 root 2, and that's negative 15 times 2, which is negative 30. See how I got negative 30 there? Negative 15 root 2 times root 2 is 2, so when you multiply it together you get negative 30. So in the numerator, 24 take away 30 is negative 6. Negative 18 and positive 20 is plus 2. The denominator, 4 times 4 is 16. Now 3 times 3 is 9, and root 2 times root 2 is 2. So it's 9 times 2, that's 18, and it's negative. So we have negative 6 plus 2 root 2. And then in the denominator you have negative 2. 2 goes into everything evenly. So negative 2 and negative makes positive 3. Negative 2 and 2 makes negative 1. And you get the answer 3 subtract root 2. All right, you did your homework. I know it's not easy, but you practiced through it. Mr. G Math, over now.